Let's take a look at section 11.1, using normal distributions. So in front of you right here, we have this equation. This equation is of standard deviation. In Algebra 1, if you were fortunate enough, you had encountered this equation on how to finding standard deviation. Now, you may say, if you didn't, well, just a real quick explanation on what standard deviation is. It is a measurement of how data is dispersed in relation to the mean. If you take a look at this equation that has the big old square root, you have x1, x2, x sub n, which right here, all that represents data from a given set. Now for us, we could say, a lot of times it's used, let's say, in tests. So x1, x2, x sub n, that would represent all of the different test scores. And then you've got that funny looking u that has a little tail in front, and we call that me. And what that actually represents is the mean. So in this long equation, let's say if we have like 5 test scores and we want to find the standard deviation, we would take one test score and subtract that from the mean, and then square it, and then add that with the next test score, subtract it from the mean and square it. And then we do that depending on how many, in our example I just said, we have 5 test scores. And so we'll do that 5 times and then divide that by n. And then we take the square root of all that, and there you have standard deviation. And so we do have calculators that help us find standard deviation, but we're not going to worry about finding standard deviation today. So down below right here, we do have this bell curve, is what we call it, and that bell curve demonstrates normal distribution. Okay, so we have right here this bell-shaped curve, as you can see. And so remember, we do have me, which is that lowercase u right there, and that happens to be what the median, or sorry, the mean is, the average. Remember, mean and average represent the same thing. And so let's break this down a little bit more. And before we do that, let's go ahead and take a look at a few vocabulary terms. We have normal distribution. Once again, that's a bell-shaped curve right here. A normal curve right here is a bell-shaped curve that's symmetric to the mean. And let's take a look at standard normal distribution, and a normal distribution with a mean of 0 and a standard deviation of 1. And then finally, we have the z-score, which is the z-value for a particular x value and is the number of standard deviations the x value lies above or below the mean, or me. The reason why we call this a bell curve, and when you take a look at normal distribution and statistics, we typically would like to see a bell curve, or what we call a normal curve. And down below now, you have right here some percentages. We've got some numbers, and that talks about the area under a normal curve. So a normal curve with the mean and standard deviation has these properties. Okay, the area under a normal, under the related normal curve is 1. Think 1 being 100%. And the first part right here is about 68% of the area lies within 1 standard deviation of the mean. So what exactly does that mean? Haha. Well, if we take a look right here, I drew a line that goes through the mean, me. And let's just say in test scores or in a class, we'll represent that with 75%, okay, or having a score of 75. And when we talk about 1 standard deviation, it's going to be this line that I'm going to go ahead and highlight with blue. We have 1 standard deviation greater or 1 standard deviation less than the mean. And you can see right here we have this 68%, okay? It would be preferred, and it would be typically when it comes to, let's say, a test, we have most of the scores between this area. So the area could be between, now we would have to calculate that with using the equation that I first showed you. And we could determine how much is one standard deviation. It could be maybe 10%. It could be 5%. So let's just say it's 5%. We could say that if we take a look at one standard deviation to the left, if it's 5%, then that line would represent a score of 80. Okay, and then to the right of that orange line, one standard deviation less would represent 70. So what we are saying right here is that 68% of the data in this little example that I gave is between 70 and 80%. That's where most of the test scores lie. That would be good. Okay. So then what we could say next is that, well, what if we have two standard deviations? Well, let me go ahead and go one more line to the right and one further space to the left, and that green line will now represent another standard deviation. So we're going to add 5 to that and have 85 and 65. So now what we could say is that the area between 65%, or a score of 65 and a score of 85, will represent 95% of the students in the class and their test scores. Well, let's now go another standard deviation out, or a third, and that would represent another 5 points. And we have right here 90, and then all the way to the right-hand side, and then all the way to the left-hand side, that would represent a score of 60. So 60 and 90 represents 3 standard deviations, to the right and also to the left. And so now, if we take a look, what we could see here is that 99.7% of the area lies within 3 standard deviations of the mean. Or that's where almost all of the student data or test scores would be. Now, maybe we have scores that are above 90. We have some scores that are below 60. But you can see, based off of the percentages, there shouldn't be that much. So you could see right here to the right, we've got this another normal distribution, and it breaks down the area of each of the sections here, of each standard deviation. And so you're saying, where does this 68% come from when we take a look at the left? It's going to be adding 1 standard deviation, which is 34 and 34, as you can see, hopefully, right here on the normal curve to the right. And so where does the 95 come from? It comes from adding 13.5 plus 34 plus 34 right there, and then that 13.5 altogether, that gets us 95%. And then when you add 2.35 to the both left and to the right, that gets us a total of 99.7%. Now, there will be times where you're going to see that sometimes the curve isn't going to always be a nice bell curve. There are 2 other instances to briefly touch on right now. What you could see is, instead of a bell curve, a nice bell curve, this one right here, we have the curve is going to be, we'll say, is skewed to the left. And when it's skewed to the left, what this tells us right here is that the mean is going to be less than the median. We could also have right here our data where this will be skewed to the right. And what that tells us is that the mean is greater than the median. So let's go ahead and take a look at a few of these examples. So right here, what I have is our normal curve And the question says a normal distribution has mean and standard deviation. And then find the indicated probability of randomly selected x value from the distribution. So the first thing right here is number 1 says, what is the probability of x being less than or equal to the mean minus 2 standard deviations? So I'm going to go ahead, I have right here, conveniently, our normal curve, and I'm going to look for mean minus 2 standard deviations. And I'm going to go ahead, you can see that I had drawn a line to the left, right there. And what it's saying is, what's the probability of a value being less than mean minus 2 standard deviations? And so what I'm going to need to use are these two numbers, 0.15 and 0.23. Both of those right there combined, 2.35, having both of those combined together will equal the probability that we're looking for. And so that is going to be equal to 2.5%. They may ask you to have it as a percentage. You may also need to take this and convert that to a decimal, which is 0.025. And that right there is number 1. Let's take a look at number 2 right here. Let's go ahead. I'm going to use my my normal curve. Let me erase some of the stuff there. And let's take a look. Number 2 says, what's the probability that x is going to be greater than or equal to the mean minus 3 standard deviations? So that will be all the way to the left right here. You can see where I drew my blue line. And everything greater will be the 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. So we're going to have to add all of that up, or what we could do, which might be easier, is put 1 minus 0.15. And that will get us the total of everything that I just highlighted in yellow, which is 0.9985. And that right there is your probability that x would be greater than or equal to negative 3 standard deviations. Let's try another one. We have right here for number 3, we've got the probability that x is less than or equal to the mean plus 2 standard deviations. So this time, the mean plus 2 standard deviations will be going to the right side of the mean, and there's my blue line. And then x is going to be less than or equal to all that. So it's going to be 13.5, 34, 34, 13.5, 2.35, and 0.15 altogether. So if we go ahead and take all of that and add it up, and I'll go ahead and write all that down right here. All of this will end up getting us 97.5. It is 0.975. So it's quite a bit of the area under the curve. Let's take a look at number 7. So number 7 says the scores for a math course test are normally distributed with a mean of 61 and standard deviation of 11. So remember, mean, we use this me symbol, which happens to be this U with a tail. Standard deviation is this O with the little squiggly on top. And if we take a look right here on to the right, I've got our normal distribution. Let me go ahead and let's start filling things out. I would recommend on your homework to draw something like this so that we could take our data and split it up accordingly. So the average or the mean is 61, so I'm going to go ahead and put that right underneath mu, right there in the middle of our normal curve. Then we have a standard deviation of 11. So what that tells me is that if I go 1 standard deviation plus 1 to the right and minus 1 to the left, I'm going to add 11 to my mean. So going 1 standard deviation to the right is going to be 61 plus 11, which will be 72. If I go 2 standard deviations, I'm going to add another 11, and then so 72 plus 11 gets us 83. And then if we go 3 standard deviations to the right, or positive, then 83 plus 11 will get you 94. Let's take our standard deviation and go to the left side. Minus 1 standard deviation will be 61 minus 11, which gets us 50. For negative 2 standard deviations, we have 50 minus 11, which is 39. And then 3 standard deviations will be 39 minus 11, which gets us 28. So now we have our data split based off of our mean and standard deviation for test scores ranging from 0 to 100. So it says, what percentage, in part A, asks what percentage of the students taking the test have a score between 72 and 83? Well, let's take a look right here. Between 72 and 83, I'm going to go ahead and highlight that with yellow, is that spot right there. Now, we have to think, well, how much is that? Remember, one of the tables that we had earlier showed us the percentage of each section. Remember, the 1 standard deviation, and let's just go up right here. If you look, 1 standard deviation is 34%. 2 standard deviation is 13.5. So if I were to now go over here to the normal curve that we had, between 61 and 72, that's 34% of the data. Right here in yellow, that's going to be 13.5%. So it says what percent of the students is taking the test and have a score between 72 and 83? It's going to be 13.5% right there. It's the part highlighted in yellow, between 1 standard deviation and 2 standard deviations. Let's go to part B. In part B says about what percent of the students taking the test have a score less than 50. So let's go ahead and erase some of this right here and take a look. 50 is 1 standard deviation to the left, or minus 1. So don't forget, at the mean, we have 61. Between 61 and 50, that's 34%. Between 50 and 39, which is 2 standard deviations, that's going to be 13.5%. Let's take a look between -2 and -3 standard deviations, and that right there is a total of 2.35. And then everything less than 0.25, less than 28, a score of 28 is 0.15 right there, percent. So about what percent of the students taking the score have less than 50, we're going to take 13.5 plus 2.35 plus 0.15, set that all equal, and that gets 16% right here. If I had those in decimals, then it would be 0.16. Since it's already in percentage, 16%. And there you go. We found our answer. All right, let's take a look at the next question right here. Take a look at number 8. We're going to do the same thing, okay? They tell us the temperatures of a city are normally distributed over a course of a year. The mean temperature of 55.2 Fahrenheit and a standard deviation of 6.3. So the mean, 55.2, so I'll put that right here in the middle of our normal distribution curve. 55.2, and then one standard deviation is 6.3. So if I take 55.2 and add 6.3, that will get us 61.5. Let me add another 6.3 to that number. That gets us to 67.8 for two standard deviations. And for the third one, we have 74.1 degrees. Let's go one standard deviation. Let's start going to the left-hand side, where we're going to subtract 6.3 from 55.2. And that gets us 48.9. Subtract another 6.3 from that, and that gets us 42.6. And when we subtract another 6.3, we now have 36.3% right here. So we've got our intervals set up with our mean and standard deviation. And then let's go ahead and start solving things out. Okay, so it says, what is the probability that the chosen day is 45 degrees Fahrenheit or cooler? So if I'm looking at 45 degrees Fahrenheit or cooler, well, we do have a little bit of a problem right here, because we don't necessarily have 45 degrees, right? We do have a little bit of an issue. So what do we do right here? What we need to do is figure out what our z-score is. The score that we have is not nicely or evenly lined up with our standard deviation. So our z-score is going to be where z is equal to x minus me divided by standard deviation. Okay. So right here in this instance, they're saying that we want to find 45 degree Fahrenheit. Well, so let's go ahead right here and find that z is going to be equal to 45, and then minus our mean, which is going to be 55.2, and then we're going to divide that by 6.3. Calculating that, we get negative 1.619. And so now, what do we do with this? What do we do? This number, what we're going to have to do is use a table and compare that with a table to help us figure out exactly what our probability is going to be. So now what I'm going to do is take a look at the standard normal table. Now this table right here, it's an abbreviated table, and you could find this right here on page 598 of your textbook. So on this table, let's take a look and find negative 1.619. We'll abbreviate this to the nearest tenth and look for negative 1.6 right here, okay, since our table only goes up to the 10th. And so if I look for negative 1 right here, and then I go to 0.6, I see that right there I've got this number of 0.548. All right, so let's go ahead, I'll write that down. This in turn goes to 0.548. And there you go. What is the probability that a chosen day is 45 Fahrenheit or less? It happens to be that number of 0.0548. And that is the probability. They didn't ask for a percentage, so we're going to go ahead and just go with that number right there. For part B, it says, what is the probability that a chosen day is cooler than 32.5? So let's see, 32.5, it doesn't land within our standard deviations right here. So we're going to have to go ahead and, just like what we did, figure out our z-score. And let's take the number 32.5. We're going to subtract that from the mean, which is 55.2, and then divide that by standard deviation of 6.3. And this gets us approximately negative 3.603. So for our intensive purposes, this will be negative 3.6. So let's go back to our table right here. Let's take a look at negative 3, and then I go to 0.6. We get ourselves 0.0002. So we have 0.0002, and that right there happens to be our probability. Next up, what is the probability that is chosen between 32.5 and 45 degree Fahrenheit? Okay, so let's take a look at our two numbers. It's going to be between the two. So let's go ahead and take 0.548 that we found in part A, subtract right here 0.0002, and then we'd be able to get our probability, which is 0.0546. And there you have part C. All right. From there, part D, I think at this point you probably know how to do that and you should be able to find it. But let me give you the answer so you can try it out, and you should get 2.119 as your probability. For the last part here, let's take a look at 9 and 10. Okay, and we want to determine whether the histogram has a normal distribution. Remember, a normal distribution has a bell-shaped curve. So we want to try to find, do we have ourselves something that's bell-shaped? If I take number 9 and I kind of follow the way the bar is shaped, it goes from left to right, it goes up and then it stays up. It doesn't come back down like a bell-shaped curve. So simply, we say that that is no. On number 10, this looks like it has more of that bell-shaped curve. And although it's not perfect, it does look like the mean happens to be in the middle of our bar graph. And so for this one, we will say yes. All right. And there you go. We just finished up 11.1. We were taking a look at right here using a normal distribution. All right. If you have any questions, make sure you leave a comment or make sure you ask me in class. And don't forget to work on your assignment. All right. Bye-bye.